In this video, we're going to continue our discussion with rational functions. The last asymptote I would like to talk about is what is called the slant asymptote. Okay? And this will be when the degree of the numerator is higher than the degree of the denominator. Okay? If you divide it, and especially if the degree is 1 larger, okay, then the line that is formed without the remainder is what is referred to as the slant, or what can also be called the oblique asymptote. Okay? All right, so let's determine and write the equation of the slant asymptote. So it's asking for us to divide. So again, similarly to what we talked about earlier in this course, you have 2 different options on how to divide, either long or synthetic division. Because the denominator is in a nice form, I am going to do synthetic division. Okay, so put in the numbers. So this is read as x plus 12 plus 56 divided by x minus 3. But 56 divided by x minus 3 approaches 0. So the slant asymptote is going to be y equal to x plus 12. That is what my slant or oblique asymptote is going to be. Okay, one other example. Now this one very clearly I cannot use synthetic division. I'm going to have to do long division and put zeros in for my placeholders. So again, x cubed times what gets me to x to the 4th? Well, that is x. So multiply. Subtract. So now, what do I multiply x cubed by to get negative x cubed? Well, that's negative 1. So now multiply. Now, negative 2x squared has a smaller degree than the divisor, so we're done here. So the slant asymptote is x minus 1, y equal to x minus 1. Okay, so now that we've talked about all of the different types of asymptotes, I'm going to skip to the very last page of this handout, where on the top it should say write a rational function giving the following information. So now I want to be able to write a rational function given all the asymptotes and x-intercepts. So the first one should say vertical asymptotes at x equal to 3 and 7, horizontal asymptote at y equal to 6, and a whole at x equal to negative 2. Well, first of all, I'm going to call the function f of x. Okay. Now, vertical asymptotes, they are found in the denominator, but I'm not going to put x equal to 3. I'm going to write it as a factor. That is x minus 3. Similarly, if the 0 is 7 there, the factor is x minus 7. Horizontal asymptote, I'll come back to. The whole. Well, the whole is both going to be in the numerator and the denominator. And again, if it's negative 2, the factor should be x plus 2. Now, let's go back to that horizontal asymptote then. So I know it's going to be 6. Now, the only problem is, in order to have a horizontal asymptote that is not 0 or none, the degree of the numerator must be exactly the same as the degree of the denominator. Now, I don't want to take x plus 2 and cube it, because that would get rid of the whole. So notice the degree of the denominator is 3, the degree of the numerator is 1. So if I multiply the top by x squared times x is x cubed. Now the degree of the numerator and the degree of the denominator is exactly the same. Now I can have a horizontal asymptote at y equal to 6. Okay, one other example I want to take a look at then. Okay. All right, so we have a vertical asymptote at -2, x equal to -2, x-intercepts at 2 and 4, a hole at x equal to -5, and a horizontal asymptote at y equal to 0. So again, I'm going to call this f of x. Okay. All right, so horizontal asymptote, and will be x plus 2 on the bottom. X-intercepts, you're going to find those on the top. The whole you are going to find both in the numerator and the denominator. Now, in order to have a horizontal asymptote of 0, the degree of the numerator must be smaller than the degree of the denominator. Well, the degree of the numerator is 3 because I have x times x times x, which is x cubed, and the degree of the denominator is 2 because x times x is x squared. Again, I don't want to put an exponential power with x plus 5 because that's going to affect my whole. But if I take x plus 2 and cube it, well, the degree of the numerator is still 3. Now the degree of the denominator is 4 because I have x cubed times x, which is x to the 4th. And now the degree of the numerator would be smaller than the degree of the denominator. There is where I could get my horizontal asymptote at y equal to 0. So now I would like to go back to this particular page where it says on the top, for each rational function, write the domain in interval notation, calculate all intercepts, determine all holes and asymptotes. If there are none of a certain type, explain why. And then we're going to try to graph the function. All right, so we have f of x with this rational function. My suggestion to you would be, if possible, factor both the numerator and the denominator, because then very quickly you'll be able to tell what your holes are going to be and what your vertical asymptotes are going to be, okay, among other pieces of information. Well, I can factor the top as such, and factoring the bottom. Now, I can tell very quickly I have no holes because there are no common factors in both the numerator and the denominator. Now, I can also tell you the domain restrictions. So for part A, x cannot equal 4, and x cannot equal -1. So I can draw this on a number line very quickly. And again, I should have 3 different intervals for this with a domain. Okay. So my domain is this. Okay, next, let's take care of the intercepts. X-intercept, we know f of x is 0. Now, we talked earlier in another earlier video, where is a fraction 0? It's when the numerator is equal to 0. So right now, I'm going to take the numerator and set it equal to 0. Now again, we've already factored this. So again, solving, we know x is equal to 3/2 and x equal to 2. Now I am going to write this as an ordered pair so I can graph these later on. Okay, y-intercept, I know x is equal to 0. So what am I going to do? I'm going to do f of 0. Now, I'm going to go to the original function right here because that's easy to plug in. Plugging in 0 on the top, that's 0 minus 0 plus 6 is 6. On the bottom, it's 0 minus 0 minus 4 is -4. That's -3/2. So the y-intercept is at -3/2. Okay, asymptotes and holes. Okay. Now again, I can make this note very quickly. No hole, since there are no common factors. Okay, vertical asymptote. Well, vertical asymptote is when the denominator is equal to 0. So we know one vertical asymptote is at x equal to 4, and the other one is at x equal to -1. Okay, horizontal asymptote. Well, let's check the degrees. The degree of the numerator is 2. The degree of the denominator is 2. So what does that mean? I will take the leading coefficient of the numerator, divide it by the leading coefficient of the denominator. So remember, horizontal asymptote, y equal 2. Leading coefficient on the top is 2. Leading coefficient on the bottom is 1. My horizontal asymptote is y equal to 2. Okay. All right, slant asymptote. Okay. None, since the degrees are equal. Because remember, the definition would tell me the degree of the numerator must be bigger than the degree of the denominator. That is not the case for this. Okay. All right, so what I would like to do is to at least start graphing on the coordinate plane here what I have so far. Well, first of all, I'm going to change this to f of x, and I'll label these. Okay, so what? I have 3 halves and 0, and I also have 2, 0, and I also have 0 and -3 halves. All right, so in a different color, we have a vertical asymptote at x equal to 4. And now we have a vertical asymptote at x equal to -1. And I have a horizontal asymptote at y equal to 2. Now, we know for a fact that the graph is never going to cross the vertical asymptote. But it is possible that it could cross the horizontal asymptote. So let's check that. Wow. We know the horizontal asymptote is y equal to 2, and we know y is equal to f of x. So what I'm going to do is go back to the original. Instead of f of x, I'm going to put 2, and I'm going to rewrite this function again. So 2x squared minus 7x plus 6, and then divide it by x squared minus 3x minus 4. So I want to solve this equation for x. Okay, I'm going to multiply both sides by x squared minus 3x minus 4. So that's 2x squared minus 6x minus 8 equal to 2x squared minus 7x plus 6. Notice the 2x is subtract out. Okay. Add 7x to both sides. Oh, let me erase. And add 8. So at the ordered pair 14, 2, I am going to cross the horizontal asymptote. All right, so now we need a couple other things to happen here. Number one, is the graph going to be here or here to the left of x equal to -1? Well, without a graphing calculator or Desmos, I don't know. So I could plot points. So what's a number that is to the left of -1 on the number line? Well, that's -2. So if you do f of -2, okay, you should get 14/3. So I can write this as an ordered pair, -2 and 14/3, which is exactly the same thing as 4 and 2/3. Okay? So we're going to pick one other value because I need to figure out what's happening to the graph on the right-hand side of x equal to 4. Well, what number on the number line is to the right of x equal to 4? Well, there's a bunch, but I'm going to pick 5. If you plug in 5, you should end up getting 21/6, which is exactly the same thing as 7/2, which is exactly the same thing as 3 1/2. Okay? So now what I want to do is to plot these 2 points. In fact, I'll do it in a different color. Maybe we'll pick red here. So what? Negative 2 and 4 2/3. Okay. And what else? We also need to do what? 5 and 3 1/2. Okay, now, so for a fact, we know this is not going to cross the horizontal asymptote any other time. So let's connect stuff. Not crossing the vertical asymptote, but now we know we're not crossing the horizontal asymptote anywhere else. Same. Okay. Now, so there is a sketch for this. Now, what I would like to be able to do is to show you this on Desmos. So, looks very, very similar. Now, notice, anything past 14, it is well below 2. And anything before that, that 14 is slightly above 2. Okay? But at 14.2, that's when we begin to go below x equal to 2 for this.